Right, cortex, because we clearly got the corpuscle. These tubular profiles belong to what? Surrounding the renal corpuscle? So what tubules?
Proximal
Sing it out,
convoluted.
I'm a deaf old man. Proximal distal convoluted tubules. Yeah, no trick question, just lay it out. I throw this in, clearly the filtration barrier is dear to my heart because the ultrastructure is so pretty. But here again, we've got an erythrocyte, fenestrated pores, this basement membrane, remember, rather basal lamina, and the pedicels here, the foot processes. So things are moving through here. You may ask yourself, if you filter things, filters get clogged, how does the kidney deal with that? Well, there's a cell called a mesangial cell that actually chews up basement membrane and then new stuff is laid down. So there's a continual renewal there. Again, another image dear to my heart. Clearly looking at a filter here. How can you not love a podocyte? Well, look at this guy. All these nice processes, interdigitating. Okay, do you see evidence of a juxtaglomerular apparatus in this image? Yeah. Here's your macula densa. And look, we just cut through the wall of this afferent arteriole, and here, a little further on, we've got the lumen. So this is a vascular pole. This would be the region of the urinary pole, but we're not seeing the continuity with the proximal convoluted tubule. You think that's a distal or a proximal convoluted tubule right there?
Distal. Distal.
Distal.
Yeah.
Because the luminal profile
Oh.
is pretty clean right here. Same song, second verse. Again, another, and if you spend any time looking at your kidney slide in the cortex, you're going to see more and more of these juxtaglomerular apparatus. So here's afferent arteriole, and here's macula densa. So we've got to have left the cortex and we're down in the medulla. What are we going to call this right here? Either I'm getting deafer or you guys are turning the volume down to work me over here. It's a thin portion of the loop of Henle. You can see nicely in this prep all of the vasa recta. That's probably a collecting duct or tubule. I'm saying that because you can almost hallucinate the intercellular borders. And this is another really nice shot. Clearly transmission electron microscopy. But we've caught that abrupt change where the thick descending cuboidal epithelium stops and the simple squamous epithelium of the thin loop begins, but we cut it tangentially, so we get both. Here you can see the brush border or the microvilli of the proximal tubule straight portion. And here you can see the simple squamous. Over here, well actually, here and here, you've got distal tubules. And note, clearly that luminal profile is a lot cleaner than this one because all we've got in the way of microvilli are these little stubby protuberances. Transitional epithelium. And we're too high powered for you to tell me whether this is bladder or ureter, all right? What's the difference between bladder and ureter? How do you tell the two apart?
Muscle layers.
Exactly. I mean, the bladder is just lots of smooth muscle in the wall, big, thick, arranged every which way. The ureter section, you know, if you have the adventitial portion, you're going to have a little bit of smooth muscle and then fading into connective tissue. All right, so don't make it harder than it has to be. The key thing is a transitional epithelium and then using your head in terms of thinking about thicknesses of muscle. All right, moving to the male reproductive histology. This some of you have this orientation, where basically you cut the testes on its long axis, and you can see the epididymis. All right? Many of the slides I looked at were cut this way and didn't have much in the way of epididymis. But it did have a nice mediastinum. I've seen some of the best greedy testes that I've seen in years. So you've got that going for you. You just are missing the epididymis. These tubules up here, if you looked at higher power, you would see that the epithelial lining, the luminal profile kind of undulates. I want you to think back to Nigel's lecture where we talked about the efferent ductules having ciliated columnar, absorptive cuboidal columnar, so that's what you're seeing. So even at a low power, you can pick out the 10 or 20 efferent ductules from the epididymis itself there. Nice shot of seminiferous tubules. Clearly kind of a longitudinal profile, mostly circular. What's this up here? Yeah, the interstitial cells of Leydig, producing testosterone. Let's go a little higher power I believe I have here. So you can see that basement membrane and those myeloid cells that surround it. See the lumen of the seminiferous tubule. If you start Sertoli cells, as Nigel pointed out in his lecture, you really aren't, particularly paraffin section at light level, not going to see the cytoplasm of the Sertoli cells. But their nuclei are characteristic. Look at this guy right here. So they're kind of not so much circular, maybe a little angular. And they've got this, most of them have a nice dark staining nucleolus. All right? So Sertoli cell. Sertoli cell, I should say Sertoli cell nucleus. All right? Another one, another one. Here's one right here, 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 here. So, I mean, once you get your search image honed in on it, they're everywhere, as you expect them to be. If we think about the spermatogonia, these nice round nuclei, cells that are resting on the surrounding basement membrane. All right? Everything, particularly above the level of the Sertoli cell nuclei, are spermatocytes, except for these puppies right here, which we would call spermatids. And as soon as they undergo the process of spermiogenesis, they will become spermatozoa. So they need to go through some morphological changes before they're ready to do what they do. Another nice blood vessel here. Nice, beautiful clump of interstitial cells. I'll put this one upside down, no matter. This is a transmission electron micrograph of an interstitial cell of Leydig. And remember, a week before last, we talked about the ultrastructural signature of a steroid-secreting cell. Lots of smooth ER, mitochondria with tubular cristae. So clearly, Sertoli cells are cranking out steroids, and in particular, testosterone. No, did I say Sertoli cells? Interstitial cells of Leydig are cranking out testosterone. Epididymis, as Nigel mentioned, this is a pseudostratified columnar epithelium that is stereociliated. So again, think of stereocilia as non-modal in that they lack the axoneme and the ATPases to drive the movement. But think of it as a super long branched microvilli. All right? Same song, second verse, you can see the kind of crew cut of the stereocilia right here. Okay, when we're talking about seminal vesicle and prostate gland, you can read what we say in the lab manual and text about the epithelium lining the spaces. I just shine that on, okay? We're going to go for more of a low power gestalt here. If you look at this, your impression is a lumen that is plicated, or the mucosa is thrown into folds. You know, as has been mentioned before, superficially similar to the ampulla of the oviduct, where you have that big folded mucosa. Here, if you think you're looking at oviduct, what are you going to be looking for on the epithelium? Cilia, ciliated cells, simple columnar. But what about those peg cells? Those dark, non-ciliated cells that are interspersed? So if you look at an image like that and you think, it could be oviduct, could be seminal vesicle, go to high power and try to find peg cells. If you see peg cells, you got to think oviduct and forget seminal vesicle. All right? The other thing to keep in mind is that the seminal vesicle, each one is a blind-ended sac that's folded on itself. So even though there's no confluency between this space and this space, above and below the plane of section, these lumina are all confluent. Okay? So folded mucosa, no ciliated cells, no peg cells, makes it seminal vesicle. If we look at the prostate, as has been mentioned today in lecture, your first impression is big fibromuscular stroma with lots of little glands. Remember, there are 30 to 50 of these tubulo-alveolar glands. So that, at a low power look, is a lot different than this profile right here. All right? The thing that's nice about the prostate, and unfortunately I don't have a great shot of it, although we don't need it now. This is cool. See these little black? They look almost black, brown. Those are the prostatic concretions. All right? The thing to keep in mind, I'm not sure that this, well, here's a higher powered prostatic concretion. Oftentimes they look like they have tree rings. So they've been added at different times. The accretion has occurred over time. So they can, like in this, right here, even though they're microscopic from your point of view, they can be brown, yellow, or sometimes pink. But look for the tree ring factor, the concretion, and that'll take you home. That's all she wrote.
Can you go backwards?
Yes, of course.
See that top left, that's
Right? Yeah.